Okay, this time if I'm given 105, sine of 105, use half angle formula to solve. So the first thing I'm going to do before I even start anything else, I'm going to say sine of theta over 2 is equal to, okay, so first of all, I just write my half angle because it told me to use my half angle formula and I'm working with the sine function. So note off to the side, since we're working with 105 degrees as regular theta, we want to rewrite this as theta over 2. So how else could we write that? Using a fraction. Double it and divide it by 2, right? Isn't that the same thing? 210 divided by 2 is 105, but this is in a fraction form so that it meets this. Okay, so we will calculate the sine of 210 degrees divided by 2, which that's still 105. It's just fits our format of our formula. Okay, now let's think this through. 105 is in which quadrant on the unit circle? The degrees is a little bit easier. First of all, this is 90 and this one's 180, so it's clearly going to be in quadrant 2. So that's just a note we're going to make, that we're just going to remind ourselves that we're in quadrant 2, and we need that for the sake of this sine value. So what is the sine value? We'll deal with that. Let's deal with that at the end. Let's go ahead and start working on our 1 minus the cosine of theta. What is theta here? Theta divided by 2 formula. What's our theta? 210, right? Cosine at 210 degrees. And I'll make a note over here that that's theta divided by 2 so you can see how clearly that's going to be 210. And then it's just over 2. Let's just bring this sine down. 1 minus, what is the cosine at 210? So what if we go to the unit circle? Let me see if I still have it here. Whoops. What is the cosine at 210? Negative square root of 3 over 2. Yeah. So we can actually use our unit circle to evaluate this. Negative square root of 3 over 2. To plug that value in, and then of course I just have that over 2. Let's get a common denominator in our numerator, which is a 2. So that would be, we're just going to work with this. So it's going to be 2 minus a negative is plus, and the square root of 3 I just leave there, all over 2. Let's multiply by the reciprocal here. And this process should start to be a little bit more familiar to you now. And that means everything in the denominator will cancel. 1 times my numerator is just going to be 2 plus the square root of 3. What about my denominator? 2 times 2 is a 4. Okay, good. Square root of 2 doesn't simplify, square root of that, so I'm going to leave that alone. Square root of 2 plus the square root of 3. What about the square root of 4 though? Yes, it'll come out, and that's a 2 that's in the denominator. So I want to be sure that I do that. Okay, and the last thing we want to do is check our sine. Okay, we want to know the sine of theta, and theta over 2. Where is theta over 2 going to be? Is going to be in the second quadrant. So what is the sine value? Sine value in the second quadrant? Positive. So oops, we can, at this point, or we could have done it in the very beginning. Wait, I'm on the wrong part. So this is positive. Good. Okay, number 6. Use a half-angle formula to find the exact value of cosine of 3 pi over 8. Now, we usually have to figure out which quadrant we're working in. So when I go to my unit circle and I look for 3 pi over 8, I don't necessarily see it. Now, one of the tools I could use that may be helpful, and many of you prefer this, is to convert 3 pi over 8 to degrees just so I have an idea of where it is. So how will we do that? 180 over pi, and that simplifies to, which is going to be roughly 67.5. So which quadrant is 3 pi over 8 in? 1. So that's just a side note. Degrees is easier to tell, but let's leave it in radian. So I'm going to move this over for a minute, and I'm going to say, well, if theta over 2 is equal to, we want to figure out what theta is in this case. So this is like a theta over 2. Let's let theta over 2 equal to 3 pi over 8 and cross multiply this and see what we get for just theta itself. So that's just going to be 8 theta. This is just one method that can help you. 2 times 3 is 6 pi. Then we're trying to get theta by itself, so let's divide both sides by 8 and find out that theta is going to be 6 pi over 8. Let's go ahead and simplify it while we're at it, which is 3 pi over 4. Okay, so what we found is this is in quadrant 1, but theta itself is in quadrant 2. 3 pi over 4. So our half angle, which we're given this is in fraction form, so it's in our half angle form, but our formula requires cosine of just theta. So that's what we did just now. We found out, we used our information of the half angle to find out what theta itself is going to be, so that we'll be able to calculate this value here. Alright, so, and let me just clear that up. So cosine of 3 pi over 8 is also equal to the cosine, it's like 3 pi over 4 divided by 2. Okay, so this is in half angle form. You could see it there. That's if it was in theta divided by 2. Just a side note, if this confuses you, that's fine. We could just stick with this, but I did want you to see the relationship between the two. Alright, so let's come back and start calculating. Alright, so plus or minus, let's do 1 plus, what is the cosine of theta? And theta is going to be 3 pi over 4 divided by 2. What is the cosine of 3 pi over 4? Let me pull that back up real quick. 3 pi over 4 right here, what's the cosine value? Good. So let's write that down. This is going to be negative square root of 2 over 2. You should know the drill by now. We're going to work with our numerator and get a common denominator of a 2. So that would be 2 plus a negative is minus the square root of 2 over my denominator. Okay, and we're going to multiply by the reciprocal. Multiply by the reciprocal. The numerator is times 1, so I'm just going to get 2 minus the square root of 2. And then 2 times 2 right there is 4. Okay. Square root of 2 minus the square root of 2 doesn't simplify, but what about the square root of 4? It's 2, but it's in the denominator, so it's going to stay in the denominator. So we'll have this value right here. Last thing we need to do is determine our sign, positive or negative, right? Okay, we jot these down. First of all, we remind ourselves theta itself was in quadrant 2, but we're not talking about theta. We're talking about cosine of theta over 2, which is this one. And where did we say this was? Quadrant 1, right? So what is the cosine value in quadrant 1? Positive. So we want to, at this point, determine that it's going to be positive and say cosine of theta over 2, so the half angle.